Hello, today we're going to be continuing our discussion on section 8.3, which is on areas of circles. In a previous lesson, we discussed our formula for area of a circle. Area of a circle is equal to the product of pi times the radius squared, or area equals pi r squared. First, I'd like to recall finding the area of a circle with a radius of 6 feet. In this on your own question, I'll go ahead and lead you through it first, just to warm up. And then I'll ask you to do number 5 on your own. So area is equal to 3.14 multiplied by the radius of our circle, which is 6 squared. If you need to draw a picture to picture that radius, you may. My radius is 6, so make sure that we do have the radius and not the diameter, and drawing the picture helps you visualize that in fact we do, but also we are told in the question that our radius is 6 feet. Remember, we must do our exponents before we multiply, so 3.14. 6 times 6 is 36. And lastly, we just need to multiply the 3.14 times 36. If you want to use a calculator for that, it's probably a good idea. So I have 3.14 multiplied by 36, and I get a product of 113.04. So area is equal to 113.04. My units are feet. And since we're talking area, which is a two-dimensional surface, we want square feet. It will take 113 feet that are all in the shape of a square to fill up the circle that we're referring to. On your own number 5, I'd like you to go ahead and take a moment to pause the video and try by yourself. Our area is equal to pi r squared, and they tell us to use 22 over 7 for pi. Our radius needs to go next, squared. Now drawing this picture, we have the diameter, which is 28 feet, but what we need is the radius going from just the center to the edge. So that's going to be half of the diameter. So if the diameter is 28, half of that would be 14, meaning that our radius is 14. So on a calculator, I'm going to multiply 14 times 14, because remember we must do our exponents first. 14 times 14 gives me 196. So area is equal to 22 over 7 times 196. Now I'd like to just mention why they have us use this 22 over 7. Notice that in that fraction we have a denominator of 7, or we're dividing by 7. Well, 14 also divides by 7, so eventually what we're going to be able to do is reduce these two things with one another, and that's what I'm going to do right now. The 196 I'm going to put over 1, and I'm going to reduce these two. And the reason I know that 196 reduces by 7 is because it came from the 14, which reduces by 7. So I'm going to get out my calculator and divide 196 by 7. In doing so, I get 28. So what I just found is that if I divide 196 by 7, I get 28, and I can reduce 7 by 7 and get just 1. So now I've got area equaling 22 over 1, which is just 22, times 28 over 1, which is just 28. And our numbers became much nicer now that we've reduced. So now I just need to find my area by multiplying 28 by 22, and I get a total area of 616. So the area of this circle is 616 meters. Again, since we're talking about a two-dimensional surface, I want square meters. In example 2, we want to find the distance that a monster truck travels when the tires make one 360-degree rotation. Which best describes this distance? So I'm going to go ahead and just draw what we might picture as a tire. So imagine this is your tire. We are going to rotate this tire 360 degrees, or we're going to take this point and we're going to turn the tire all the way around until we land back to where we started. That's a 360-degree rotation, just turning the circle all the way. The radius of the tire is going to be the measure from the middle of the circle to the edge. Now that doesn't relate to the outside of the tire and how far it's going to travel when the tire rolls. The diameter of the tire will not either. The diameter is just how big the tire is, not necessarily how far it's going to go. The area of the tire just tells us how much space the tire takes up, not, again, how far it's going to go. But the circumference of the tire, if you imagine this point turning around the outside of the tire, will be how far the tire is going to go. Or you can almost imagine unwinding the circle. So if I just took this point and unwound the circle into a flat line, something like this, instead of wrapping around the outside, we would be able to determine how far the tire is going to go. So I'm going to push this tire, it's going to roll and unravel until the entire thing is flat. So circumference of the tire, or the outside of the tire, is going to tell you how much ground this tire is going to cover in that one rotation. We're going to now go into finding areas of semicircles. Now a semicircle, as we've learned before, is just half of a circle. So if I have this orchestra pit, I want to go ahead and figure out how much area is in just that semicircle. We're not talking about the stage here. We're just going to be talking about this red orchestra pit. So if it were a whole circle, we can imagine this. If it were a complete circle, I could find the area by just going pi times the radius squared. However, it's not a whole circle, it's only half a circle. So once I've found this, I'm going to go ahead and divide by 2. First, I need to find my radius. So my radius is the distance from the center to the outside. Notice that this distance here goes all the way across the circle. I only want from the center to the edge. So that's going to be half of that distance. The whole distance is 30, so my diameter is 30, which means my radius is only half of that, which is 15 feet. So area is equal to 3.14 times 15 squared. So I take my calculator and I'll go ahead and multiply 15 by 15 to get 225. So area is equal to 3.14 times 225. And then from there I just need to multiply by 3.14. So times 3.14 to get 706.5. The area of our orchestra pit, if it were a whole circle, is going to be 706.5 square feet. However, we don't have a whole circle. We only have half of a circle. So I now need to take that orchestra pit and divide it in half. So the area that we're looking for is actually 1/2 of 706.5, or 706.5 divided by 2. Punching this into my calculator, I find that 706.5 divided by 2 is 353.25. So the area of just the orchestra pit is 353.25 square feet. So to recap, we found a whole circle and then divided by 2 so that we only had half of the circle. In question number 6, I'm going to do the same thing. Area is equal to pi r squared. I have the whole distance across my circle. If you were to draw this guy out, the whole circle has a diameter of 8. But I only want the radius, so I'm going to go ahead and divide that diameter by 2, and I find out that my radius is 4 meters. So area equals 3.14 times 4 squared. Notice I'm using 3.14 because my radius doesn't have any factor of 7 in it, so it wouldn't reduce with the 22/7. Area equals 3.14. 4 times 4 is 16. And multiplying on my calculator, 16 times 3.14 is a total of 50.24. So the area is equal to 50.24 square meters. Now this number here that we just found is for the whole circle, but we don't have a whole circle. What we actually have is only half a circle. That blue part is just 1/2 of that total area. So I need to go erase the rest of that other half of the circle and divide this by 2. So the area that we're actually looking for is 50.24 divided by 2, when I take this 50.24 and divide by 2, I get 25.12. So my area is actually 25.12 square meters. In number 7, we're going to go ahead and do the same thing. Area equals pi times the radius squared. We're going to pretend this is a whole circle and find that area first. And really what we're finding, just to make this a little bit more clear, is this circle if it were all shaded in. One thing that might be confusing is why we aren't adding in the diameter like we did with perimeter. Now if I shade in this whole circle, what I really want is only half of the circle. The red part that I'm looking for is just half of the circle. So what I'm going to do from here is I'm going to divide this whole circle after I find the entire area by 2. Once I do that, once I take this circle and divide it by 2, what you're going to notice is that we have half of our circle remaining. We don't need to add in anything back because what we want is already all covered. So the first thing that we need to do before we proceed is to find our radius. Now the 5 yards that they give us goes across the entire length of our circle, so this is our diameter, meaning our radius is half of that. So our radius is going to be 2.5 yards. So area equals pi times 2.5 squared, and that pi is 3.14 since my 2.5 doesn't have any factor of 7 in it. First thing I'm going to do is multiply that 2.5 on my calculator by 2.5. So 2.5 times 2.5 gives me 6.25. So area equals 3.14 times 6.25. Now remember that what we're finding here is actually the area of this circle if it were whole. So we're going to need to continue our multiplication, but then we're going to need to take into account the fact that we are finding a whole circle, not just half of a circle. So I multiply 3.14 by 6.25, and I get a product of 19.625. So the area of this whole circle is 19.625. However, again, we only have half of a circle. So if we want to go ahead and erase the whole top half of this circle, just so that we're left with the bottom part that we want, what we need to do is divide this by 2. So the area that we're looking for is 19.625 divided by 2, and on my calculator I see that that is 9.8125. So my area is 9.8125. My units are yards, and area is two-dimensional, so we have yards squared, or square yards. Go ahead and take a moment to pause the video and try number 8 on your own. Notice that they do already give you the radius, so you just need to plug these numbers into your formula and divide by 2 at the end. I've got area equaling pi r squared. Area equals 3.14 times 11 squared. On a calculator, 11 times 11 is 121. So area equals 3.14 times 121. Multiplying by 3.14, I get 379.94. So area equals 379.94. But what I found is the area of the whole circle, and what I want is only half the circle. So I need to take that area and divide by 2, 379.94 divided by 2, and I find that the area of this semicircle is 189.97. My units are centimeters, and since we're talking area, I have a two-dimensional surface, so I have centimeters squared, or 189.97 square centimeters. That concludes our lesson on area of circles. Thanks so much for watching.